Okay, hi everyone. Welcome to our webinar today. So I'm Karen, and I want to welcome you to this online thing that we've got going on. It's called Creating 3D Models Using Photography, and presented by Vincent Solomon. Just a little bit of housekeeping. We recommend using Chrome or Firefox while watching this. You'll have a much better experience, and rather than mobile Safari or Safari Opera. And I also want to introduce Juan, who's with us today. So Juan, you want to say hi?
Hi everyone, I'm very happy to be here again in another of our webinars. For those who are attending for the first time today, we have been having more webinars and you can find all of them in our YouTube channel. I'm a 360 photographer and a Unity developer, and I do think photogrammetry is a great option for us people in the 360 field, and that's why we have today our expert in the field, Vincentiu.
Yeah, I just wanted to, for those of you who aren't familiar with IVRPA, we are a nonprofit organization that's completely supported by our members and our sponsors, and it's entirely operated by volunteers. So our mission is to provide resources in nearly all aspects of 360 panoramic photography, videography, and we're really pleased to have this webinar today. So I'd like to, welcome Vincent. It's great. I'm pronouncing his name Vincent because I can't pronounce it correctly. Vincent. Yeah. So he's a motion designer, animator. He's working in animation, 3D visualization, and he's going to be presenting how to go into photogrammetry directly from using our images. It's going to take about an hour, and we will have we will have a Q&A at the end. If you do have a question, I suggest using the Q&A tab. It's at the top of the chat window there, and this way it's kind of separated, and we can mark if it's there. Like, it's easier to read. So, good. Okay. Well. Good luck, Vincent. I leave it over to you, and I'll be in the background here. Enjoy this, everyone.
Thank you, Tanya. So hello, everyone. It's really a great pleasure to be here and share my experience with you. And thank you to the International Virtual Reality Professionals Association team for giving me the opportunity to be here. So now, let's see. Let's just activate the slides. So Karen, I would have to ask you for help for the slide. Okay, great. Thank you. So, great. I would like to do a quick poll to see how many of you have already worked with photogrammetry and who already has a basic understanding of how the process of photogrammetry works. So I'm going to launch the poll now. Okay. Okay, so let's give it a second. Okay. Okay, that's interesting. It seems like we have, the majority of you have not had yet experience with photogrammetry. So yeah, that's great. So I'm not usually so I'm usually a participant at these kinds of webinars. So bear with me while I try to adjust to this new formula. So I work in a studio in the middle of the Italian Alps. The studio is called Bocek, where we do product staging through 3D animation and film. And before we begin, I would like to show you our short reel so you can have a better idea of what it is that we do, and then we can dive in deeper. So just give me a sec. Okay. Okay, so okay, enjoy. Okay. Okay, so, well, as you can see, there is a lot of variety in the work that we do. But what I want to talk about to you guys today is specifically photogrammetry. So first I'm going to give you a brief introduction about what photogrammetry is for those that are not so familiar with it. Afterwards, we'll talk about one of the projects I worked on this year and give you an idea about the workflow and what gear and software you need to build something similar. While going through the project, we'll go over some theory and some tips that will help you get a satisfying result. If we manage with time, at the end of the presentation, we'll do a live demonstration. So on how would you go about building your first 3D model using just your smartphone? Those of you interested will be able to follow along by downloading the pay-per-input version of Reality Capture and creating an account from their website. The process should be pretty straightforward if you did not do it already. Everyone should have received a link to download a set of photographs you can use while following along. At the end of the presentation, there will be a 10 minutes Q&A. So if you have any questions, just write them inside of the Q&A tab, and I'll be happy to answer them. So yeah, let's get started. So photogrammetry, what is it? Photogrammetry is the process of taking multiple overlapping photographs and deriving measurements from them to create 3D models of objects or environments using dedicated software. So think about the process of creating a panorama in Photoshop. or Lightroom or PTGUI for that matter. That is, by stitching together multiple overlapping photographs, you get a 2D mosaic of images. The underlying principle is very similar in photogrammetry. The main difference is that it takes this concept one step further by using the position of the camera as it moves through 3D space to calculate X, Y, and Z coordinates for each and single pixel of the original image. This is also known as structure from motion. So I will share with you briefly. Let's see my screen so you can see better what I'm talking about. So you can see here this object where this is a project that we are working on. So this is a brief overview of what actually structure from motion means. So if you look closer, there are lots of points that help visualize this boot. There is no actually a mesh right now, but as you can see, the cameras around the object are projecting. Let's see if I can make this more obvious by increasing the scale, maybe, of the actual cameras, and you can see how the program managed to align these cameras and build this highly dense structure that it's helping you visualize the object. So okay, let's see. Okay, so as some of you may know, photogrammetry gives you the ability to create highly accurate and realistically photo-textured models of objects of various forms and sizes, as well as buildings, archaeological sites, and big landscapes. So what is so special about it? What can you do with photogrammetry? Imagine an historical artifact, like, let's say, fossils, that need to be preserved and studied without the risk that it may be damaged by simply handling it or exposing it to the elements. You can imagine how this can be so valuable for researchers, also for museums, virtual reality, AR experiences. The possibilities are really, really endless, especially in situations like the one we are right now, where museums are actually closed and you can't experience them in person, at least in some cities and countries. So close-up photogrammetry, in this case, offers the possibility to digitally preserve an object, in this case, these artifacts, before they may be lost or damaged. Also, it allows you a whole range of digital measurements and analysis that can be performed, and that allow and that give researchers insights into the actual material that might not be visible to the naked eye. As an example, in these images you are seeing right now, you can see some 3D reconstructions that some years ago, for the archaeological site museum under the city of Verona in Italy. This was an interesting project. The place was huge. was a huge underground, is a huge underground museum. And of course, it was very dark with almost no decent light whatsoever. Unfortunately, I have no behind the scenes footage to show you more, but I'll try to give you an idea of how I managed to light all these areas. So every 3-4 meters, I had to 3 to 4 meters. I had to move 3, if I recall correctly, 3 powerful lights together with the camera, so that I could evenly light the scene. You can have a sense of the scale from, if you look closely, there is a rig. I added right there. So that gives you an idea of the actual scale of these places. The rig, the character has is almost at real world scale. So okay, so for these projects, I had to take around 2,000 images on average per scene, and I used most, if not all of them, for one scene, which was pretty crazy in terms of computation as well. So let's see, there should be another one here. So as you can see, this one in particular was was a very big and difficult to light, because this particular region of the museum was right under the historical streets of Verona. So right above this passage in the middle, there were some small windows that the people from the outside could see under. So the light was very uneven, and yes, in this case, it was particularly difficult. Yeah. So okay, so let's go forward. Okay. So now let's talk a bit about the Little Matterhorn, a project we did as a studio this year that took around 2 months from pre-production to delivery. While talking about some of the main steps of the project, we'll go on short tangents and dive a little deeper into the process itself, while covering some theory. So for those who did not yet see the video of the project, I'm just going to play it once now, so everyone will have an idea of what we're going to talk about next. It will be around 1 minute, and yeah, I hope you enjoy. Just give me a second to switch the screen. So, okay. Application. Okay, enjoy. Okay. So, well, as you can see, there is a lot going on here. There are, let's see the slides. So, there are additional elements used in this animation, like the actual 3D buildings of the stations, the animated cabins, and some other objects like towers, ropeways, lights, and some other snow around the stations that help blend them together. And of course, the two mountains, the Little Matterhorn and Testa Grigia. One of the main things to consider when having to work on big projects like this is finding the right partners that can help you, so that can help and add value to the final result, and that are great to work with. And most importantly, you can trust them. You don't want to find yourself in the middle of a production and people freaking out because a problem just materialized. We were on the field for 2 days to capture everything we needed. So Alp Vision helped us with the drone equipment, and Alto drones helped us to plan the flights. Our partner Spheria 3D took around 30 panoramic pictures and stitched them together to create a 360-degree background, living out the parts with the mountain where we were standing on. So this gave us the freedom of choosing the angle we liked most. So if you haven't already seen, there is on our Vimeo that I will share at the end of the presentation, there is a making of this project. So you will be able to see some footage of our behind the scenes. So, okay, so one of the biggest challenges we encountered while we were shooting on location was most definitely the weather. In the mountains, weather is very unpredictable, and we were hoping that it would not slow us down too much. We were mostly lucky, but we had to deal with continuous back and forth of cloudy versus sunny situations. So we'll be talking more in detail about this kind of issue shortly. On one other aspect we had to face was freezing cold and, of course, strong winds. Using drones during windy situations can get tricky. Because of the cold temperatures, we had to change pretty frequently the batteries for the drones. If you have ever been in very cold areas, you probably experience an unusual fast drainage of your smartphone's battery. If you ever find yourself shooting in cold conditions for prolonged periods of time, make sure you can have access to a power plug nearby. So Alp Vision was prepared for these kinds of situations and brought with them a special case that kept the batteries nice and warm while unused. If I recall correctly, the case was, I think, custom made. So also, it might seem obvious, but if you have to shoot in a different state or country that use different power plug sockets, make sure you have an adapter with you. That's really very, very important. So, okay, so now, what do you need in terms of hardware to get a satisfying 3D model, a great 3D model? Generally speaking, feature photography is the only stage of the whole process that necessarily takes place in the field. So it's not always true though, since of course smaller objects or even people are scanned indoors. In this image, you can see this particular setup was made in a lorry, in a big truck. So if you're curious to see how do these people work, you can search for the scan truck, and you will I think you will be amazed of the work that they do. So they have a photogrammetry studio that is mobile, so they can be wherever the client needs them to be. Okay, so this particular step is executed by gathering a series of conventional photographs taken with a standard digital camera and lens. The two models of the mountains generated in the project you just saw of the Matterhorn were produced from around 2,100 raw photographs using aerial photography with some pictures taken up close, so we could get some additional details. So I can let's see if I can share again the screen. So just give me a sec. Let's see this one. So as you can see, this morning I launched a quick recalculation of the Little Matterhorn using the same pictures, but of course I used a lot less details in the settings, so that it would be ready for me to show you. So as you can see, you can clearly see how the drone actually flew over the mountain, and what type of path it took to create this model. So as you can see, some of them are going like straight forward and in a straight line, and some other pictures were taken from lower, so that we could capture more details around the area that we needed to capture. Okay, let's see. Stop sharing. Okay, so we used a digital. So we used a DJI Inspire 2 drone equipped with the X5S camera and about 20 pairs of batteries we used to take the pictures. Total flight time, as you can see, was around 275 minutes during the 2 days of shooting. Okay, so if you're not using drones, the best choice, of course, is to use a DSLR or a mirrorless camera. I'm sure it's not your case, but one might say, well, I don't have a DSLR camera, or maybe I can't afford one. So I would say, as long as your smartphone has at least a 5 megapixel sensor, you can use that and get a really great result, as you will see at the end of the presentation with the live demonstration. Regardless of the camera you actually use, so one thing you should avoid that is very important is you should avoid ultra wide angle and fisheye lenses, since these types of lenses create distortions that confuse the software during calculations. So almost never. So if you can, try to never use lenses under 16 millimeters. So, okay, just step back. So some applications now have a very neat and useful feature that allow for automatic lens distortions compensation if the EXIF data for every image is present. If you can avoid these types of lenses, I strongly recommend to do so. It will save you from trying to figure out why the model isn't exactly what you expected, and you will get much better results in the end. So what focal length is best for photogrammetry? Well, it depends. Generally speaking, a lens with a focal length between 50 millimeters and 70 millimeters on a full frame sensor is ideal, but it's not always the case. There are exceptions, as I'm just going to show you. So look at this image, for example. This work is by Felix Dodd that we discovered just really recently. He photographs and creates 3D models of super tiny insects and bugs with incredible detail. It's actually pretty stunning. In this case, you would opt for a super macro lens and maybe focus stack the images so you have everything nice and sharp. In our project, we used the DJI with 17 millimeters lens, if I recall correctly. Although this particular focal length although it's quite wide as a lens, and the distortions are noticeable up close, in our case, we were at least 50 to 100 meters above. So above the surface, so distortions were not really an issue. So yeah, let's go forward. Okay, so what about your PC setup, desktop setup, or Mac setup? In most cases, the size of your project will be influenced by the amount of RAM you have available. So building the geometry is the most important, and so I will reformulate. So building the geometry is the most most memory-intensive process, especially if you want a model with a highly detailed mesh. Memory consumption is also very dependent on the resolution of the photographs. Overlap, so is highly dependent on the resolution of the photographs, overlap, and actual number of photos. So to give you a general idea, for 200 photographs at, let's say, 24 megapixels per image, you should be fine with 32 gigabytes of RAM at high detail. Let me just add that every photogrammetry software has some kind of settings that allow you to choose the level of detail you want. In the case of Little Matterhorn, we used reality capture with 64 gigabytes of memory, and the whole process worked really flawlessly, I would say. So while memory might be a limiting factor in terms of maximum project size, CPU and GPU will determine the actual speed of the calculations your PC will be able to do. So you can use whatever graphics card with CUDA capabilities you already have on your machine, if any, of course. In our studio, we work a lot with 3D applications and GPU renderers, and we need to have as much CPU and GPU power as we can afford. So as soon as a project is completed, we can launch and finish the final render as soon as possible. Since we were able to work with multiple GPUs at once, of course, we took advantage of this while working on the project, and it definitely sped up the process a lot. So to summarize, the more CUDA cores you have on your GPU, the better. So I think I forgot to add that you don't have to have necessarily an NVIDIA card in this case. You can use AMD cards, for example, that work just as well. Okay. So as for CPU, you should have at least a 6-core processor. I mean, well, a quad-core would work, of course, as well. But if you think that this kind of work is what you want to do on a regular basis and not just once every month, the more cores you have, the less time you have to wait for the calculations to finish. Remember that the process itself is pretty intense, and you might not be able to do very much on your computer during this time. So I would recommend what I recommend is to launch the calculations during nighttime. So in the morning, you have your model ready to be processed further. Okay, so next, how many images do I need per object, and what are some best practices to get good pictures? As a rule of thumb, a minimum of 20 photographs is necessary to get a decent reconstruction. Of course, this depends on your model, but if you do just a 360 around the object, 20 photographs should be enough. So take a look at, let's see. So yes, so take a look at this image. It's an image I have to admit I found it on Google, but it was pretty clear. So take a look at this image. Let's say you have an object in the middle. You should take a photo at least every 15 degrees around the object, and approximately 30 degrees up or 30 degrees down. You can do this more than once. So if you want more details, of course, you can go even lower than 15 degrees. You can do every 5 degrees or even 2 degrees. So I'm going to show you now let's see. I'm going to show you a screen of Lightroom. So here you can see you can see in this case, if we flip through, just a second, it always gets me this. Okay, so if we scroll through these images, you can see that these pictures were taken at less than 15 degrees. This is because we chose to do a lot more to get as much detail as possible from the model. So as you can see, there are also different angles of the same object. So I think it's pretty clear that the pictures taken are very near each other, let's say. Okay, it's forward. Okay, so you can, let's see. So you can, so you can do this by using a turntable and a tripod, or by hand, by going physically with your camera in hand around the object. It should be obvious that the sharper the image, the better the final result. Well, if you have available a tripod and a turntable, I would recommend to use them, because it will help remove shakiness of the camera, and it will be a lot more precise. Okay, so also I think I wanted to mention how important lighting is. While indoors can be pretty easy to control the light, outside can be tricky, since daylight and especially sunlight can create harsh shadows, and this can influence a lot the final outcome. So I think I have an example. Yes, so this is an image of the drone took while we were over the little Matterhorn. So here you can clearly see this very very obvious shadow. This is never a good thing, but let's see. This is never a good thing, but in our case, since what we needed was an animation of the scene that was that had let's say that we had to animate the perspective of the camera from far away. We were able to let's say hide these kinds of issues. So I'm let's see. Okay. So for best results, you want to have even light from all angles. This is especially important for a good outcome of the final texture. If you don't need textures, this aspect might be very well overlooked. Also, if you want to avoid changes in light during your photography sessions, remember that even your shadow might be captured on the textured model as well. So let's say if you have a bright source of light behind you, even if it's a soft source of light, if you put yourself between the light and the object, that will be captured on the model itself. So let's say you have an object standing under a type of light that creates harsh shadows. The photos you took might work well for reconstructions, but the final model will have a textured with, I like to call it embedded light, like and and this might limit your creative possibilities in other 3D applications, since you will have to stick with the actual light and shadows you already have on the model. So while working with the model in another 3D application, you would have to recreate the same source and direction of the light to avoid having shadows in different directions. Yes, so with an even soft light on your texture, you will not have, of course, these kinds of limitations. One of the things that you also must avoid are reflective or wet surfaces, because the actual reflection itself changes pretty rapidly between shots. Even if you have the camera a tiny bit, so even if you move the camera a tiny bit, the images become inconsistent, and the software can't find enough common points between them to do the calculations properly. Sometimes you can work around the problem if you have light reflections. Like yes, if you have light reflections, you can use polarized filters that go with your particular lens, and you can remove some of them. But in my experience, the results may vary a lot depending on your actual model and environment. When we shoot for photogrammetry, we usually choose a plain background, like a green screen or a white background, because we are since we are working with reality capture, we found this particular program works great with this kind of setup, and it's a lot easier for us to manage the actual photo shoot. So as you have seen a bit earlier, the images of the boot were taken with seemingly white background, as you can see in this example here. So, well, I should say that if you use a green screen, you should really check to not, that when you use green screens, sometimes it happens that there is a little spill of the green color around the object. So you would have to check if that's an issue with your particular model. But using a white background, that's usually not really a problem. Yes. So should you use JPEGs or raw images? So if you have a powerful machine with at least 32 gigabytes of RAM, and depending on how many images you have, I would definitely go with the raw versions, since you have a lot more information with raw images compared to JPEG files. Also, JPEGs may introduce a lot of noise that may be harder to remove in post, and can make your model look a bit, how would I say, mushy. So yes, so cameras these days, it's true that cameras these days handle really well the noise at high ISOs settings, but whenever you can, it is keep it as low as possible. So so yeah, as I already mentioned, in our project we use around 2100 photographs. This might seem like a big number, but with with vast landscapes, this number can go even higher pretty fast. So, okay, so what about software? What you want to do after you have downloaded your photos on your computer is to open them using your favorite image editing software. If you're not using them raw, of course. So we went for Adobe Lightroom because it's pretty easy to use. So I'm guessing many of you are already familiar with it. It has a pretty straightforward UI, and it gives you the ability to import all your photos into specific catalogs where you can manage and work easily on them. Some of the main things that I do to all images that need post-production is correcting the white balance. Let's see if I have. So it's correcting the white balance, reducing shadows. So let's see if I can share again the screen. Okay. Okay. Yeah. So let's take this example. Okay, so the main things I do on images that need post work, like this one, for example, as you can see, the before image on the left it has a lot of contrast, and the yellow sole under the boot is pretty blown out. I'm guessing that's because the type of color and material. So in this case, you would want to color correct a bit the image, since as you can see on the left one, I mean, I don't know if you can really see the difference, but there is a slight yellow tint. So in this case, I corrected the white balance. I reduced the shadows so that we can have a flat look. Let's say that is very good for reconstruction. So as you can see here, I removed some of the shadows and reduced the highlights. And also, I think, well, in this case, I don't think I removed noise, but I will do that if the image requires. And also added a bit of sharpness, just a touch. Okay, so, and of course, let's see if I did, but so yeah, and some other times I would remove contrast by using the slider in Lightroom, but in this case I just went for highlights and shadows. Okay, so the secret. Oh, just give me a second to come back. Okay. So the secret is really to obtain a flat image with little to no strong shadows. So as you have seen the example earlier, this will be really useful for the texturing stage of your model. If you let's see, yeah, I want also to mention that raw files taken from a camera on a tripod and with an ISO under 200 usually can be used with no further post-processing in your photogrammetry software of choice, since almost any app now accepts native files. So as for the photogrammetry software, we use reality capture as a primary choice. In my opinion, it has the most straightforward workflow with a very simple and clear UI. There are, of course, lots of other options. Some of the most popular ones are Argisoft Metashape, 3DF Zephyr, and I will add here the free one, that's probably the most famous one, LS Vision Mushroom. That is also pretty easy to use. I don't have much experience with it, but I've tried it a couple of times. But it's really a great option for for if you want to test it out with no paywall. So most of these programs work essentially in the same way. So the first step in the calculation process is the feature extraction from the images. This step allows extraction of pixels that do not change between camera viewpoints. The next is the alignment of images. So between each other, so between the images, much like Photoshop does when you are creating a panorama. But in this case, the software has to consider the position of the camera as well. So it can create a point cloud like this one. And subsequently a depth map. At this point, should be pretty clear from the viewport if the reconstruction will be a success. You can see from the following image that from the point cloud, you can clearly determine if there are any relevant issues. So let's see if I can give you an example. Actually, we will go. I will show you this during the live demonstration because that will be a great, a great occasion to do this. Okay, so after our point cloud is ready, we can either go straight to the mesh generation or color the point cloud so we can have a general feel for the colors of our object. The process of coloring is generally pretty fast and straightforward. It's one of those steps that are not always necessary for the final mesh generation, but yes, it's useful if you want to see yes, a draft, let's say, of the model. So mesh generation is one of the most computationally intensive steps. Depending on the level of detail you choose, it can take a significant amount of time to complete. That's why this step is maybe best to do it, as I already mentioned, to let it process by night. So after mesh generation is finished, and after you checked that the model is what you were expecting to get, you can proceed with texture generation. So in most apps, you can choose the texture size up to 16K, which is crazy big and really heavy to work with. Usually 8K is more than enough for most projects. The calculations for the mesh reconstructions of Little Matterhorn took about 6 hours to finish. We had satisfying results after the first try and proceeded to export the model and texture for further processing. So we work in Cinema 4D. There we did everything else you saw in the final animation video, from cabin animation, snow reconstruction, so yeah, materials of the additional objects, lights, of course. So in the case of Little Matterhorn, we had to match the light of the shadows that were captured with the virtual light, let's say. So yes, okay. So I would say that now we reached the end of the presentation part of this webinar, and now I would like to do a quick live demonstration to show you how easy it is to actually get your first 3D model using just your smartphone. If you have downloaded the images and reality capture, you can follow along. Otherwise, you can use the images to practice or use them after the webinar is finished, because I think it will be uploaded to YouTube sometimes, I think in the next few days. So, okay. So I will assume that those interested will have already the images and software ready. So now I'm going to share my screen. Let's see. Okay, so the first thing you want to do after you have downloaded your images is to upload them to reality capture. So the way reality capture works is really intuitive. So you just have to click on input. You have to navigate to your folder where you have your images. You can so you can select them all and click open, or you can also just drag and drop them from a file directory directly into this panel over here on the left. So I'm going to do open now. So okay, so before I do this, I think I will want to okay, so I'm going to do a new file, and I'm going to do the process from again. Okay, so I'm going to select them all, open. So you will have your images right over here. If you click on this little box with a plus in it, you will see every single image you uploaded. Also, you would be able to see if you upload images that you took with your DSLR, you will be able to see over here on let's say on the same line of your image, you would be able to see the settings at which the image was taken. So in this case, I used my phone. The images you see here are all taken with my phone almost a year ago. Oh, that's more than a year ago. So I found this mask hanging on a fence while I was while I was trekking, and it seemed to me really interesting. So I took the images to do just that, to do a test with in photogrammetry. So now, after you have uploaded your images, you can inspect them over here. If some of the images you think they are not useful and you don't need, you can just delete them. Also, so the first step of this process is really simple. After you have loaded your images, you just go to alignment and just click align images. Of course, if you want to do specific things, you can go deeper in this in the settings of reality capture. So just a second. Okay, so you can go over here on settings and change how the program will calculate the actual the alignment of the images. If you want more detail, if you want more precision, you can do that from here. So usually I don't really touch this section over here because the default settings gives me a pretty satisfying result. So as you can see here, you can clearly see the structure from motion that we talked about at the beginning. So you can also clearly see the direction from which I took the images. Since the mask was attached to a fence, I wasn't able to take the photos from behind. So yes, you can clearly see this from this. So after this step, you can. Oh, I should mention that the actual alignment in this case was, as you noticed, pretty fast, because of course we have very few images and the resolution is pretty low, and in this case, as you can see, it was pretty fast, and it seems that the result is also really promising. After this step, you would have to go on the reconstruction tab. Let's see. We will do normal detail with default settings. So after I start the process, I think it will be a great time to answer some questions because it might take a couple of minutes. So if I don't know if there are already some questions in the Q&A section, but I'm going to launch it now. And yes, I will try to answer some questions in the meantime. It should take a couple of minutes, but let's see. Where is it? Okay. Okay, I'm gonna keep. Okay. So let's see. So Marcus Morba asks, is there a software you can recommend to be able to use 360 panoramic photos for photogrammetry? Well, I have to be honest, I don't know if I know about that. I can't recall if there is a way to use 360 panoramic photos for photogrammetry. I would like to say that there isn't any, but I might be wrong. So I think I think I'll have to look for that. I can't really answer that, unfortunately.
Vincentiu, I can add something related to this question.
Yeah, sure.
I was talking to the reality capture company. They say they are developing a new feature that will be able to support the use of 360 images for photogrammetry. It's not ready yet, but well, sometime in the future they will have it. And as long as I know, I was finding information on the forums, and I think Agisoft, I don't know if I'm pronouncing well the the name.
Yeah.
I think they have been experimenting also with 360, but what I found in the forums when I was looking for this information is that probably 360 photos are not the best source of images for photogrammetry. So that's why, probably because of the same reasons that Vincentiu was mentioning, and the fact of avoiding wide angle lenses. Well, that's what I knew about it.
Yeah. Thank you very much, Juan, for the input. I really I didn't know about that, so I'm thankful, and I hope Marcus Morba had its question answered. Okay, so. Okay, Juan asks, do you think, is there any time of the day that is best to shoot, like noon, for example? Actually, what you want to look for when during your session is, if weather permits, if you have overcast, if you have a overcast situation, you can either shoot in the noon or in the afternoon or in the evening during summer when when daytime is longer. But if I have to give a specific answer, a more concrete answer, I would say noon, because it's the time when the light is the strongest. But try to look for shaded areas, or wait for some cloud to give you some help. I hope that was. I hope that I answered the question. So
yes, perfect. Thank you.
Okay, so again, Marcus Morba asks. So let's go in order. Okay, so Marcus Chiaudano, Marco Chiaudano asks, what about process of object with flat uniform surfaces? Well, in this case, it really depends. I mean, if you have a surface with little to no texture whatsoever that is visible to the software, that will be pretty difficult to reconstruct. So I would recommend, if you have flat uniform surfaces, even if they are really, really flat with no deformations whatsoever, try to try to look for surfaces that have at least some kind of texture or some kind of structure, or structure that gives the surface contrast. Because if you have something with some kind of texture, even if it's flat, the software can recognize that and build you a flat surface. Another example. So something else you could do is to, if you have a flat surface that is really that has little to no detail, you can add some X's. So you can use a marker or some tape, or some black tape, let's say, and put little markers on the surface, so that when you're taking the pictures, the software can recognize the actual flat surface. So if you will want to remove those stickers from the texture, afterwards you will have to do some more work in other 3D software programs. So it's another step that comes after the photogrammetry process, reconstruction. Okay, I hope I answered the question. So Marcus Morba asks again, I'm currently processing the example with reality capture, and it only uses 1% of my GPU, but 90% of CPU. Wrong settings? Well, not really. The reality capture uses, I think, I don't want to say something that it's incorrect, but I think it uses more of the CPU than the GPU. But if you have, well, I think you would also have to look on your let's say on your task manager, on the performance tab, and let's see. If you go on your task manager and select the performance tab and select your GPU, you can choose. You can choose the CUDA. Just give me a second. You can choose the CUDA section, so it can show. Okay, I'm going to share my screen now, so I can answer better in a better way the question. Just give me a second. Let's see. Okay, now my PC is slowing down because it's doing the reconstruction of the mask in normal detail. Okay, I'm going to pause it now because I can't really show you otherwise. Let's say pause. Okay, so. Oh, I think this is. Just bear with me a little bit, guys. Okay. Okay, wrong screen. Okay, so I don't know if you're able to see the my task manager, but now of course I paused the process, so I will start it again, so that okay. So if you go in the performance tab, you choose your GPU, and you should be able to see the 3D section over here, and you can clearly see that the GPU is being used 100%. I don't know what type of GPU you have. Maybe for some reason it's not compatible if it's not really working, but it should be using your GPU pretty intensely, let's say. Yeah, I don't know. I hope I answered the question, but it really depends also of the GPU you have. So, okay, so let's move forward. So Juan asks again, if I want to use photogrammetry for a real estate property or a museum indoors, how many pictures do you think it would require, and which would be your suggestion regarding the degrees to shoot photos? Also 30, distance between position of the tripod, etc. So in this case, of course, it depends on the, so regarding how many pictures it would be required, it really depends on the size of the location. So if you have a really big room, you would, or a small room, in any case, you would have to take the pictures in a way that, so if you take a pictures right here, so in front of you, the next one on the, let's say, the right side would have to overlap the first one. So I don't know, at least I would say 40 to 50% would have to be the overlap between images if you have to build something big. At least this is the way I did for the project I showed you at the beginning with the museum and the archaeological site. So I would say, yeah, it's not really a question of how long is the distance between every image, but how much is the overlap between the images, because you could use a 35 millimeters lens, and that lens will, if you do it like one image here and one image after a meter, if you use a different lens, that distance will have to change because you have less field of view. Yeah, I hope that was clear. So after the suggestion regarding degrees to shoot photos, so if you have a big space, in the case of the museum, of the archaeological museum, I used a ladder. So I climbed on top of this ladder, and I took three how do you say, three rounds of images, like from top to bottom. So you would start from the bottom, you would go on the right and on the left, and then for the second row you would have to go a little bit higher and take the same photos from left to right. So the third row you would do the same thing. So yeah, I hope that that was clear between position of the. Yeah, I hope that was clear. If that wasn't clear, please let me know.
It is clear. Thank you.
Okay, so let's see. Marcus Morba asks again, how do you solve photographic objects from below or from full 360 around, turning the object? Well, the simple answer is yes. I mean, with reality capture, it works really, really great. With the training sneakers you saw earlier, we did just that. We turned the boot upside down if we needed to take the pictures on the other side. Yeah, you can do that. The important thing is to maintain like the same setting around the object, and of course the same light. And you should be good with that. Okay, so Marco Chiaudano, it is. So Marco Chiaudano asks, I think something along the lines what Juan asked. It is possible to build model of a room from inside pictures. How to take pictures, same position or moving around the room? Well, you have to move around the room so that you would have different perspectives between images. You have to do that. That's an essential part of the photogrammetry process. So I would say yes. Okay, so Daniel Holton asks, can you show I think the best way to work the back of the mask where there is no data? Well, in that case, I would say you would have to either reconstruct the back of the mask in a different application. Okay, just a second. I wanted to share with you something regarding just this question. If you give me a second, I will come just right back to you. Yes. Okay. Okay, I'm already with you guys. Just a second. Okay, I'm going to share my screen so I can try to answer Daniel's question in a better way. Oh my, this reconstruction of the mask is really slowing my PC down. That's unfortunate. Okay, just a second. Okay, okay, I'm with you. So I hope you can see my screen now. I wanted to show you this a bit earlier, but I will show it to you now. This is the final reconstruction of the mask with, of course, the back of the mask reconstructed. So to answer your question, Daniel, a way to build the back of the mask is well by doing it yourself in 3D software. I would recommend, of course, Cinema 4D, but you can also use Blender. That is a free software, and it's really great. But yeah, if you have even basic knowledge of modeling in 3D, you can do this pretty easily. The material, the wind material you see inside here was created in a different software, and yeah, this is the final result, as you can see. So, okay, I hope Daniel, I answered your question. Okay, so I'm going to answer, I think is the last question by Juan. So when is it a good idea when is it a good idea doing photogrammetry with a DSLR and when with a laser scanner? Okay, so personally, I never worked with laser scanners, but I would say that laser scanners are useful if you work in engineering or if you have to do reverse engineering. So let's say you want to build a custom case for, let's say, a phone. It is best to use a laser scanner because the actual process of reconstruction gives you a real world scale of the object. So with that data that the laser gives you, you can build in 3D the it would be better to say in a CAD software you would build the actual case you would need for that specific object or phone in this case. But if you want to have something with very high details, I would not recommend laser scanners because they don't have the same resolution as a DSLR has. A DSLR it's much more. It gives you a much better result. It's not that. So if you use a laser scanner, it's a lot faster to build a 3D object, but you would not have the same detail. So I hope that was a clear answer.
Perfect. Thank you.
Okay, so yes, so Marcus is thanking. Yeah. Okay, you're welcome, Marcus. Okay, so let's go back to our. Let's see. To our mask. So I had to stop mine because I was not able to work with that. I was not expecting that, but let's see. Okay, so I'm going to share my screen now. Let's see. Okay, so in this case, I cheated a little bit. Of course, I've already did this prior of this presentation. I did a calculation before because you never know of what could go wrong. So as you can see, using just on the reconstruction tab, using just the normal detail, you would have a pretty good result. If I recall correctly, this took around, I think, 6 to 7 minutes. That is pretty. That's pretty decent. And just from the images from my phone, that is 4 years old, you can see that the details here, the number of polygons is pretty high, like 3.8 million triangles. That's just insane from just images from a phone. If you were to do this again in high detail, I would say you would get easily to 5 to 6 million polygons, but just by normal detail, you have a really good result here. So the next step would be to colorize this this mesh, just to have a better idea of how the feel of the texture is. So we just have to give it a second. It should be pretty fast. In fact, okay, as you can see, just by doing the coloring step without doing the texture step, you can see that already we have a pretty good representation of the final model. You can see if I get closer, the quality is pretty good. So yeah, the next step would be to texture the mask, but I'm not going to do that because it's a process that may take up to 30 minutes to an hour, depending on the actual settings you put inside here. So you can have up to 16K if you want to. So if you choose to go along and do a 4K or 8K version of the textures, you would see that the details of the mask would be a lot better than what you see here. Okay, so after this, you could do different things to this model. You could simplify the model, so you can reduce the polygons because it might be pretty heavy to use a model like this in a 3D application, or you can do different things that are pretty, let's say, specific, and yeah, it might depend on your use case. But let's just jump on the export section. So the export section is pretty easy. You would go on the reconstruction tab on the export section. You would choose model, and inside here, well, I'm not going to export it now because I would have to yes, I would have to pay for it again. And so you would choose your format for the actual, for the mesh you want to have, and yeah, that's pretty much it. If you hit save, it will ask you to, based on your inputs, on your number of images and resolution, it will ask you to pay something. So in this case, it would be $1.78. That is, in my opinion, is pretty ridiculously low. So yeah, if you confirm and go ahead to export, you would have your model with your texture in 2 different files. So after that, you go forward and you continue with your process. Okay, so well, that's the end. Or well, I should say there are 3 takeaways really fast. So 3 main takeaways. So prepare for the unexpected during shooting sessions. You never know what unpredictable situations might arise. So it's best to prepare beforehand as best as you can, so you can avoid pain during your sessions. The second one is, don't limit yourself by the hardware. Use what you have. So for photogrammetry, can be a very intensive process, but you don't have to work on big scale projects. If you keep the number of the images reasonable for everyday normal objects, you can easily work with hardware you already have. And third, find key partners to collaborate. Not everyone knows how to do everything. With photogrammetry, there are multiple steps to get to the final 3D model ready to be delivered to the final client. So depending on your project, you may have to know about photography, 3D modeling, animation, lighting, rendering, and so on. So look for people that work in these specific areas and find ways to collaborate. Or you could try to learn some of these steps yourself. And I think it's
Hi, everyone. Sorry, we've lost Vincent. I'm hoping that he can rejoin. Just a moment, and he can give us the last key takeaways that he was just discussing. I'm really sorry about that. Oh, there he is. Okay, he's coming back on. So just bear with us as he goes through the setup. There he is. Are you there? It's in. Okay, I think then we just lost him again. Sorry, everyone. These things, be prepared for the unexpected. I think that's the lesson. Let's try this again. Okay. I see Vincent has come back on.
Hello.
And there we go.
Can you hear me?
Yes, sorry about that. I'll let you keep going.
Yeah, sorry about that. I don't know what happened. I don't know if I clicked something or...
No, I think that was me. I think I accidentally clicked something. Sorry.
Oh, okay, no problem. Okay, so so I think I was talking about the third point. So find key partners to collaborate. So not everyone, as I was saying, not everyone knows how to do everything. So try to find the people that can help you do the things you need while working on photogrammetry. Okay, so we are at the end of the presentation. Thank you very much for listening. I hope I didn't bore you too much. And I hope that some of the things I shared will be useful information to someone in the audience. I would also like to thank the International Virtual Reality Professional Association team for having me. And yes, if you want to stay in touch with us and want to know on what projects we are working on, you can follow us on Instagram, Facebook, on LinkedIn. And yes, we share constantly our latest projects and experiments. We share tips and behind the scenes videos. And yes, if you have any further questions, feel free to drop me an email or a message via Instagram, and I'll be happy to answer them. So I'll now give the word to Karen and Juan, and thank you again.
Thank you so much. I think we learned a lot there. That was really nice. I personally didn't know you could do this just with the phone. So, it's really impressive. So for everyone who's still with us, I just want to say thanks a lot for joining us. Sorry for accidentally losing Vincent. I think that was me. My mouse got stuck and something clicked, and I'm really sorry about that. So later, you'll probably get another email from this session that will be for a survey to let us know what you thought about today's presentation. And as we keep on expanding our offerings, we really find any feedback really helpful, so we can make these even better as we keep going on. And just a reminder that IVRPA is run by a team of volunteers, so we be kind. And finally, another wish, if you have a wish of another webinar, we're all ears. So thanks a lot, and I hope to see everyone at our future webinars. And Juan, if you want to also say goodbye, but if you're there,
Yes,
for me, that's bye.
I'm still here. So thank you, Karen, and thank you, Vincentiu, for this amazing presentation. In my case, as I was very interested as well with no knowledge, I now know how to start in the right direction. Particularly for me, it was very interesting to know your opinion about laser scanners versus camera photogrammetry. By some reason, I don't know, I was thinking that those big projects were made with laser, but now I'm very happy that I can do it with the equipment that I have, and those three takeaways that you were mentioning are very valuable as well, like for me as a professional in the 360 field. So I just wanted to also say thank you to our audience for attending our webinars. We share this passion for this field, and as Karen mentioned, we are volunteers, so we are trying to do everything possible for us to grow as a community. That's all. I wish you guys a great day where you are, and thanks again, Vincentiu. Grazie mille, Vincentiu.
Thank you all. It was really a great pleasure for me.
Great. Thanks a lot. And yeah, see everyone next time. Bye.
Bye.